The National Electrical Code, or NEC, mandates a grounding electrode system for all buildings and structures. This system utilizes elements like a grounding rod, water pipe, or other approved grounding electrode. The primary function of this grounding electrode system is to offer a low resistance pathway to ground. This pathway is crucial for safely managing fault currents, lightning strikes, and various other electrical disturbances. NEC Section 250.24 explicitly states that the grounding electrode conductor must be connected to the grounding electrode system. Further reinforcing this requirement, NEC Section 250.52 A1 specifies that both the grounding electrode conductor and the equipment grounding conductor should be securely attached to the grounding bus. Let's consider the electrician's perspective. The electrician might express concerns about a potential hazard arising from the disconnection of the white and green wires from the neutral and ground buses within the house panel. The concern stems from the possibility of the green wire becoming energized under such circumstances. This is because the green wire is connected to the frame of the house and any metallic equipment within the house, potentially creating a dangerous situation if it becomes live. Now let's examine the inspector's viewpoint. The inspector is adhering to the NEC mandate that all green and white wires must be connected to the grounding electrode system. This is due to the grounding electrode system's pivotal role as the primary grounding mechanism for the electrical system, providing the lowest resistance path to ground, which is essential for safety and proper operation. The recommended resolution involves adhering to the inspector's guidance by installing a grounding rod and connecting it to the neutral bus along with the green wire. This action establishes the necessary grounding electrode system for the detached garage, ensuring that all electrical equipment is adequately and safely grounded, in accordance with code requirements. It's worth noting that while the NEC doesn't explicitly mandate the use of a grounding bus in the subpanel, it is permissible as an alternative to directly connecting the green and white wires to the grounding electrode conductor. It's crucial to emphasize the importance of ensuring that all connections are executed meticulously, adhering to both the NEC guidelines and any local electrical codes that may be in effect. Furthermore, it is always advisable to consult with a qualified electrician for all electrical work to guarantee safety and compliance. Let's delve deeper into the specifics of grounding and bonding to gain a clearer understanding of their roles in electrical safety. Grounding refers to the intentional connection of electrical systems and equipment to the earth. This connection provides a low impedance path for fault currents to flow back to the source, allowing overcurrent protection devices such as circuit breakers or fuses to quickly trip and to energize the circuit in the event of a fault. Bonding, on the other hand, involves connecting all non-current carrying metal parts of an electrical system together. This includes equipment enclosures, metal conduits, and other metallic components. The purpose of bonding is to create an electrically conductive path that ensures all metal parts are at the same electrical potential. This minimizes the risk of electric shock if someone comes into contact with a metal part that has become energized due to a fault. In the context of a detached garage subpanel, proper grounding and bonding are essential for safety. The grounding electrode system, which typically includes a grounding rod, provides a connection to the earth, allowing fault currents to flow back to the source. The equipment grounding conductor, which is the green wire, connects the non-current carrying metal parts of the subpanel and the equipment it serves to the grounding electrode system. This ensures that all metal parts are properly grounded and that any fault currents will quickly trip the overcurrent protection device. The neutral conductor, which is the white wire, carries the unbalanced current back to the source. It is important to note that the neutral conductor should only be connected to the grounding electrode system at the service entrance, which is typically at the main panel in a house. In a subpanel, the neutral conductor should be isolated from the grounding electrode system to prevent circulating currents. In the scenario described, the electrician's concern about the green wire becoming energized if the white and green wires become disconnected from the neutral and ground buses in the house panel is valid. If this were to happen, the green wire could potentially become a path for current to flow, which could create a shock hazard. However, the inspector's requirement that all green and white wires be connected to the grounding electrode system is also based on sound reasoning. The grounding electrode system is the primary means of grounding for the electrical system, and it provides the lowest resistance path to ground. By connecting all green and white wires to the grounding electrode system, the inspector is ensuring that all electrical equipment is properly grounded and that any fault currents will quickly trip the overcurrent protection device. The recommended resolution of installing a grounding rod and connecting it to the neutral bus along with the green wire addresses both of these concerns. By installing a grounding rod, a direct connection to the earth is established, providing a low impedance path for fault currents to flow back to the source. By connecting the green wire to the grounding rod, the non-current carrying metal parts of the subpanel and the equipment it serves are properly grounded. And by connecting the neutral wire to the grounding rod, the inspector's requirements are met. To further elaborate, let's consider the specific NEC sections that are relevant to this situation. NEC section 250.32 addresses the grounding requirements for detached buildings. This section requires that a grounding electrode system be installed at the detached building if it is supplied by a feeder or branch circuit. The grounding electrode system must consist of a grounding electrode, such as a grounding rod, and a grounding electrode conductor. NEC section 250.50 specifies the requirements for grounding electrodes. This section lists the types of grounding electrodes that are permitted, such as grounding rods, metal underground water pipes, and concrete encased electrodes. NEC section 250.166 provides the requirements for sizing the equipment grounding conductor. The size of the equipment grounding conductor must be based on the size of the overcurrent protection device protecting the circuit. In the scenario described, the circuit is protected by a 60 amp breaker, so the equipment grounding conductor must be at least a number 10 American wire gauge, or AUG copper wire. Now let's discuss the installation of the grounding rod. The grounding rod should be installed in accordance with NEC section 250.53. This section requires that the grounding rod be driven into the ground at least 8 feet deep. The top of the grounding rod should be flush with or below the surface of the ground. The grounding electrode conductor, which is the wire that connects a grounding rod to the neutral bus, must be securely attached to the grounding rod using an approved connector. It is important to note that the grounding rod should be installed in an area where it will be in contact with the earth. The grounding rod should not be installed in an area that is covered with concrete or asphalt, as this will reduce its effectiveness. In addition to the grounding rod, it may also be necessary to install a ground fault circuit interrupter, or GFCI, in the detached garage. A GFCI is a device that detects ground faults and interrupts the circuit to prevent electric shock. GFCIs are required in certain locations, such as bathrooms, kitchens, and outdoor areas. It is important to check the local electrical codes to determine if a GFCI is required in the detached garage. Finally, it is essential to emphasize the importance of consulting with a qualified electrician for all electrical work. A qualified electrician will have the knowledge and experience to ensure that the electrical system is installed safely and in accordance with all applicable codes. Attempting to perform electrical work without the proper training and experience can be dangerous and can result in serious injury or even death. Here's a recap of the key points. The NEC requires a grounding electrode system for all buildings and structures. The grounding electrode system provides a low resistance path to ground for fault currents. The equipment grounding conductor connects the non-current carrying metal parts of the electrical system to the grounding electrode system. The neutral conductor carries the unbalanced current back to the source. The neutral conductor should only be connected to the grounding electrode system at the service entrance. A grounding rod should be installed at the detached garage and connected to the neutral bus along with a green wire. A GFCI may be required in the detached garage. A qualified electrician should be consulted for all electrical work. To provide an even more comprehensive understanding, let's delve into some additional considerations related to grounding and bonding. One important aspect is the concept of impedance. Impedance is the total opposition to current flow in an alternating current, or AC, circuit. It is similar to resistance in a direct current, or DC, circuit, but it also takes into account the effects of capacitance and inductance. A low impedance ground path is essential for ensuring that fault currents can quickly and easily flow back to the source, allowing overcurrent protection devices to trip and to energize the circuit. Several factors can affect the impedance of the ground path. These include the length and size of the grounding conductors, the quality of the connections, and the soil conditions around the grounding electrode. To minimize impedance, it is important to use appropriately sized grounding conductors, make sure that all connections are clean and tight, and install the grounding electrode in an area with good soil conductivity. Another important consideration is the potential for stray voltage. Stray voltage is a small voltage that can sometimes be present on grounded metal surfaces. It is typically caused by inductive coupling from nearby electrical conductors. Stray voltage can be a nuisance and can even cause electric shock in some cases. To minimize stray voltage, it is important to properly bond all metal parts of the electrical system together. This will create an electrically conductive path that ensures all metal parts are at the same electrical potential. In addition to bonding, it may also be necessary to install a stray voltage filter. A stray voltage filter is a device that reduces the amount of stray voltage on grounded metal surfaces. Another area to consider is surge protection. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges, such as those caused by lightning strikes or power grid switching. SPD work by diverting the surge current to ground, preventing it from damaging sensitive electronic equipment. SPD should be installed at the service entrance and at any subpanels that serve sensitive equipment. It is important to choose SPD that are rated for the voltage and current levels of the electrical system. Let's also address the specific wires mentioned in the scenario. The number 6 THHN black wires are the ungrounded, or hot, conductors that carry the electrical current from the main panel to the subpanel. The number 6 THHN white wire is the neutral conductor that carries the unbalanced current back to the main panel. The number 10 THHN green wire is the equipment grounding conductor that connects the non-current carrying metal parts of the subpanel and the equipment itself to the grounding electrode system. THHN stands for thermoplastic high heat resistant nylon coated. It is a type of insulation commonly used for electrical wires. THHN wire is rated for a maximum operating temperature of 194 degrees Fahrenheit or 90 degrees Celsius in dry locations and 167 degrees Fahrenheit or 75 degrees Celsius in wet locations. It is also resistant to moisture, abrasion, and chemicals. The use of 3/4-inch PVC pipe to run the wires between the main panel and the subpanel is a common practice. PVC, or polyvinyl chloride, is a type of plastic that is commonly used for electrical conduit. PVC conduit is lightweight, durable, and resistant to corrosion. It is also relatively inexpensive. When running wires through PVC conduit, it is important to follow the fill requirements specified in the NEC. The fill requirements limit the number of wires that can be run through a conduit of a given size. This is to prevent overheating and to make it easier to pull the wires through the conduit. In the scenario described, the use of two number 6 THHN black wires, one number 6 THHN white wire, and one number 10 THHN green wire in a 3/4-inch PVC pipe is likely to be within the fill requirements of the NEC, but it is always best to check the specific requirements to be sure. The connection of the wires at the main panel to a double 60 amp breaker is appropriate for the size of the wires. A 60 amp breaker is designed to protect number 6 AWG copper wire from overcurrent. The connection of the neutral wire to the neutral bus and the ground wire to the ground bus in the main panel is also correct. This is the standard way to connect these wires in a main panel. The disagreement between the electrician and the inspector highlights the importance of communication and collaboration. It is important for electricians and inspectors to work together to ensure that electrical installations are safe and code compliant. In cases where there is a disagreement, it is important to consult the NEC and any local electrical codes to determine the correct course of action. It may also be helpful to involve a third-party expert to help resolve the disagreement. In conclusion, grounding and bonding are essential for electrical safety. Proper grounding and bonding can prevent electric shock, protect equipment from damage and ensure that electrical systems operate safely and reliably. It is important to follow the NEC and any local electrical codes when installing and maintaining electrical systems, and it is always best to consult with a qualified electrician for all electrical work.